Next, I'll talk about expressing terminating and repeating decimals as fractions. So let's start with the example 0.375. So this is a terminating decimal because there's no more digits after the 5. And if that's the case, we can express this as a fraction, 375 divided by a suitable power of 10, in this case 1000. And then if possible, we can try and simplify that. And in this case, 5 divides evenly into numerator and denominator, and we get, let's see, 75 over 200. And then now 25 divides evenly into numerator and denominator, and we get 3 over 8. So expressing terminating decimals is relatively straightforward. Repeating decimals, though, require a little bit more work. So let's suppose we start with the number 0.515151, and so on. So the 5 and the 1 keep repeating infinitely. So if I call this number n, I want to try and express n as a fraction. So one way that we can do that is by noticing that if I were to move the decimal point 2 places to the right, I would have another number that had 515151 repeating infinitely. So to move the decimal place 2 places to the right, I need to multiply by 100. And now I've got 2 equations, and the left-hand side of each equation is expressed with n or 100n, and the right-hand side is expressed with 51.515151 and 0.515151. So if I subtract the left-hand side of each equation, I'll get 100n minus n. So I'll get, actually let me write that explicitly so it's clear what I'm doing. And on the right hand side, I'll get 51.515151 minus 0.515151. It might seem a little bit peculiar why I'm doing this, but we'll see in a second why. Because now I've got 100n minus 1n, so I'll have 99n on the left hand side. And when I do 51.515151 infinitely minus 0.515151 and so on, all those repeating decimals are going to cancel out, and I'll be left with just 51. And so now I can express n as 51 over 99. And again, every time you write down a fraction, you should always think, can I simplify it, express it in simplest terms? And in this case, 3 divides evenly into numerator and denominator. So 3 goes into 51 17 times and into 99 33 times. And I think that's the simplest form for that fraction. Here's another example similar to that, but this one's a little bit more challenging. Let's suppose I start with n equal 0.4 and then repeating pairs of 29. Okay, so if I was to apply what I just applied for number 2, it's not quite going to work, because if I move the decimal point 2 places, I'll have 42.929292 and so on. But I'm not going to be able to get rid of all those repeating decimals because I've got this 4 in here. So I need to be a little bit smarter here. So instead, let me first just move the decimal point one place. So to do that, I would have to multiply by 10. And then let me try and get another number that also has 29292929 after the decimal point. So if I move the decimal point 3 places, then I would achieve that. So to move it 3 places, I need to multiply by 1,000. So now if I multiply by 1,000, I'm going to have 429.292929 and so on. And now if I subtract both sides, I'll have 1000n minus 10n on the left hand side, and on the right hand side I'll have 429.292929 ... minus 4.292929 ... And so 1000n minus 10n is 990n, and 429.292929 minus 4.292929 is 425. So n is equal to 425 over 990. And can I simplify that? You betcha, because what divides evenly into both those numbers? 5 does. So 5's into 425, I think, goes 85 times, and 5's into 990 goes 198 times, and I think that's the simplest form right there. So that's how to express both terminating decimals as fractions and repeating decimals as fractions. And these types of numbers are known as rational numbers. There's another type of real number called an irrational number, and that's where we can't express the number as a fraction.